So as of now, in chapter 5, we have discussed the Newton's first, second and third law. Now we're going to understand the contact forces. So whenever objects come in contact with one another, the action and the reaction forces are often known as the contact forces. Let us understand this by taking an example. So in this example, we have two boxes. The first one is large and heavy. The next one is the small and light. And they both rest on a smooth level floor. Now you push with a force F on either the small box or you push with a force F on the large box. There are two cases here. And we need to tell, is the contact force between the two boxes is same in either case, or large when you push on the large box, or it is large when you push on the small box. Many of you may think that the contact force will be same since the applied force F remains the same in both the cases, but actually the contact force will not be same. Let's see what is happening here. Now one thing is sure, that in both the cases the acceleration of the boxes will be same, as the net force and the total mass for the system remains constant. This is same for both the cases, so acceleration will be same. Now having said that, we'll consider the free body diagram of boxes separately for both the cases. So this is the free body diagram. When we apply the force on the smaller box, when you apply F here, right? Now when you apply the force F on the smaller box, the only force acting on the large box is the contact force, that is N1. So N1, according to the Newton's second law of motion, this should be equals to m1 times the acceleration. Acceleration remains constant, that is A, right? So the magnitude of normal force is m1 times A. Now next, if you apply the force on the larger box, then what's going to happen? So this is the free body diagram. When you apply the force on the larger box, this is the applied force, this is the contact force on 1 due to the object 2, and this is the normal force on object 2 due to the object 1. And by the Newton's third law, the magnitude of N1 and N2 will be same, right? So in the second case, the only force acting on the small box is this normal force N2. So this time N2, this would be equals to m2 times the acceleration. Here also acceleration remains same. Now clearly we know that m1 is greater than m2 because this is heavy, this is lighter. Thus for this case, in case 1, the normal force will be greater than the normal force in case 2. So we can say that the force of contact is more when you push the smaller box. So when you push like this, the contact force will be more. Now for further clarification, we'll take an example on the contact force with numerical values. Now in this example, we have two boxes of mass m1 to be 10 kg, then mass m2 to be 5 kg, and they both are in contact with each other, and they rest on a smooth and a horizontal floor. Okay, now this time you push the box with force F, and the magnitude of this force F is 30 Newton. Now we need to find the acceleration of the boxes in the A part, and in the B part we have to find the force of contact between the boxes. Now first I'm going to define the coordinate system. So this is our positive x direction, right? And the pushing force we have 30 Newton, so it is along the positive x, so we can write that the force we have 30 Newton x cap. Now the contact force on box 2 is F2 and the contact force on box 1 is F1. And by the Newton's third law, action and reaction forces are equal. So F2 F1 will be equal and they will cancel each other. So the net force on both the boxes this would be equals to this F, and that is equals to 30 Newton, because these two forces will cancel each other if we take the two boxes at a time. Okay, now from the Newton's second law we can write that the acceleration would be sigma Fx divided by the total mass m1 plus m2. Sigma Fx we have 13 Newton, m1 plus m2 is 15 kg. So on solving, the acceleration is 2.00 meter per second squared. So this would be the answer for the A part, the acceleration for both the boxes. Now next we need to find the contact force between the boxes. So for that we're going to consider the free body diagram for both the boxes separately. So this time this is the box 2 and this is box 1. Now one force is what we are applying, this is F. Then the contact force F1 due to the box 2, and here the contact force on the box 2 due to the box 1. So this is for box 1 and this is the free body diagram for box 2. Now the acceleration for both the box is A and towards this direction, so this is A, and here also this is A. Now one thing we are sure that F2, the magnitude of the contact force F2, this would be equals to the magnitude of F1 by the Newton's third law, because action and reaction forces are equal. So either you consider this case or this case, you will get the same answer. So I'm taking this one, box 2. So F2, this would be mass times mass of box 2, so m2 times acceleration, this would be F2. So m2 we have 5 kg and acceleration we have 2, so that is equals to 10 Newton. Now you may ask that why don't you take this one, you can take this box also. So this time net force is F net, we have equals to F minus F1, right? So by the Newton's third law we can write F net equals to mass times acceleration. So F minus F1 is equals to, this time mass should be m1 times acceleration. F is 30 Newton as per the question, this is 30 Newton. F1 we need to find is equals to m1 is 10 kg and acceleration is 2. Here also F1 is equals to 10 Newton. Thus the contact forces are equal, 10 Newton, the magnitude is same but the direction is different. Now think what would happen if you would have applied the force on the small box F with the same magnitude, that is 30 Newton. Now this time the contact force F2 will be equals to F2, the magnitude would be same but this would be equals to 20 Newton. Here this time this is 10 Newton, but if you applied the force here then the contact force would be 20 Newton. Thus we can say that if you apply the force on the smaller box then the contact force will be more as compared to this one. Now we'll take a little complex example to end this topic. Now in this final example we have 3 boxes of mass 1 kg, 2 kg and 3 kg respectively, and the force F is applied on the smaller box and the whole system accelerate with A. Now we need to tell is the magnitude of contact force between box 1 and 2, this would be the contact force between box 1 and 2, is this contact force is greater than, less than or equals to the magnitude of contact force between the box 2 and 3. This is what we have to tell. So do one thing, consider the free body diagram for the box 2. So I'll be representing it with a dot, a point mass. Now the contact force on box 2 due to the box 1 we have F21, and the contact force on box 2 due to the box 3, this would be F23, right? No other force is acting, friction we are not considering. Now the box is accelerating towards this side A, that means this F21 should be greater, that is why it is accelerating towards the right side. So F21, this would be greater than F23. Thus we can say that the contact force between the boxes 1 and 2 is greater than the contact force between 2 and 3. So I hope you got the problem. If you have any doubt, you can comment me in the comment box below.